Hello everyone, happy to see you here, welcome back to my channel. Hi Mathematics. Today we have very interesting and in the same way this is very tricky question from math interview. We have a times a times a equal to a plus a plus a. And a lot of students might be saying, hey mister, this is the easiest question I ever seen. A is equal to 0 because right here we have 0 on the left side and we have 0 on the right side. A product of three zeros is equal to 0 and we have addition 0 plus 0 plus 0 is equal to 0. And a lot of students say, okay, a is equal to 0 and that's it. But then I got them. What about algebraic method? We need to solve this question algebraically. We need to solve this question completely and step by step. This is a great that you can solve this question by inspection. But what about algebraic method? We need to solve this question completely and step by step. So right now, let's see what will happen when we solve this question algebraically and completely and moreover in step-by-step solution. Okay, let's look closely on the left side. Basically, we have a times a, but in the same way, we can rewrite it as a times a. We have a square, and a square times a is equal to a cube. Okay, so on the left side right here, we have a cube. Yeah, this is the same as a cube, equal to. What do we have on the right side? We have a plus a plus a is equal to 3a. Yeah, we add in the three same elements, so as a result, we have 3a. And if we look closely right here from this perspective, we have a cubic equation. So right now, let's bring this 3a from our right side to left side. Let's do this right now. So as a result, we have a cube, yeah, minus 3a is equal to 0. We have something like that. This is a cubic equation. And we can easily solve this question. We can easily factor from here our a. Let's do this right now. So when we factor our a, as a result, in our parentheses, what do we have right here? We have our a square minus 3 is equal to 0. Yeah, really great. And right now, as you can see, we factor our question. We have a product of two elements, but we can easily look closely in these parentheses. We have a square minus 3. Let's write, instead of this 3, let's write square root of 3 to the second power. So let's do this right now. As a result, what do we have? A inside parentheses, we have a square, but instead of this 3, let's write square root of 3 squared. And let's look from another perspective to this question, from inside these parentheses. We have a difference of two squares. Let's remember a really interesting, really important, like the most important school identity. We have difference of two squares. We have a square and square root of 3 square. Let's remember this identity. We have a square minus b square. This is a product of two parentheses. We have a minus b and a plus b. Really great. And right now, let's apply this formula right here. So as a result, what do we have? We have a, and inside parentheses, what do we have? A minus square root of 3. A minus square root of 3 right here we have. And we have a plus square root of 3, according to this formula. And right now, the final tricky move. A product of three elements, of three variables, of three parentheses, doesn't matter, is equal to 0 when each of these elements is equal to 0. So let's start, for example, with the first one. So the first one, a first is equal to 0, okay? A first is equal to 0. And this is our first element, a is equal to 0. Or the second parenthesis is equal to 0. Or a minus square root of 3 is equal to 0, okay? And from here we can easily solve it. From here we have a second is equal to square root of 3. Really great. So we have a second equal to square root of 3, a first equal to 0, and we have a third. It looks like minus square root of 3, but let's check it. So a plus square root of 3 is equal to 0. So from here we have a third is equal to minus square root of 3. And as you can see right now, we have two more roots, and you can solve this. Maybe if you are good in math, you can easily solve this by inspection instantly. Yeah, you can easily get that a second equal to square root of 3, a third equal to minus square root of 3, but it depends on your math skill. A lot of students say that like 95% say that correct answer is 0, and they don't fill these two roots, okay? But as you can see, algebraically, we find these two roots. Right now, let's check it, because a lot of students don't trust me. A lot of students say, why we need this method, why we need to solve this question algebraically. I can easily get all these roots by inspection, okay? So right now, let's check all of these roots right now. So in the beginning, what we had? Our question right here. So let's rewrite our question. We have a times a times a equal to a plus a and plus a. Right now, let's check it. Let's check our solutions. So right here we have check, right here we have check, and let's see what will happen. The first of all, let's a first equal to 0. So a first is equal to 0. What do we have right here? We have 0 times 0 from the beginning. We prove it, so equal to 0 plus 0 and plus 0. So we have the product of three zeros. We have 0 equal to, right here we have addition equal to 0. So as you can see, 0 is absolutely correct root right here. So we move to the next root. We're going to check the next one. So we have a second is equal to square root of 3. Let's see what will happen. Square root of 3. From here we have square root of 3 times square root of 3 times square root of 3 equal to square root of 3 plus square root of 3 and plus square root of 3. Let's see what will happen. So first of all, this product, square root of 3 times square root of 3 is equal to 3, okay? And this square root of 3 sub 3 square root of 3 on the left side. On the right side, what do we have right here? We have the sum of three same elements. So we have square root of 3, square root of 3, square root of 3. So if we keep in mind that this is, for example, our x, so we have x plus x is equal to 3x. In our case, x is equal to square root of 3, so we have 3 square root of 3, which is absolutely correct. So the second root is absolutely brilliant for us. Let's check the third one. So this one is great for us, this one is great. Let's check the third root. Okay, a third is equal to minus square root of 3, minus square root of 3. Let's check it. So we have right here minus square root of 3 times minus square root of 3 and times minus square root of 3 equal to minus square root of 3 plus minus square root of 3 and plus minus square root of 3. Really tricky expression, yeah? So right here we have an odd number of minus 1, so we have minus 1 times minus 1 equal to 1, and the final sign will be negative. And the same expression, square root of 3 times square root of 3 equal to 3, and we still have this square root of 3. So minus 3 square root of 3 on the left side. On the right side we have addition of three same elements, so as a result we have minus 3 square root of 3, and as you can see, this is absolutely great root for us. And right now the final tricky move, let's draw a graph. As you can see, all of three roots are great for us. I'm going to show you a graph from a math library, but approximately let's sketch our graph. Okay, this is our exponential function, yeah, something like that. Not like exponential, this is our cubic function, yeah, something like that right here. And we have linear function, so something like that. From here we have right here we have our linear function, and you will see this graph on from math library. I will show it this graph right here. So right here we have minus square root of 3, right here we have 0, and right here we have square root of 3. Why I draw this graph? Basically you need to draw a graph when you have this type of question, because as you can see right here in the beginning you get that a is equal to 0, and this is great. Yeah, you solve this question by inspection, but basically we have two more roots, and as you can see, two more points of intersection, which is extremely important in terms of algebra, in terms of math generally, because when you forget a root, this is really bad thing, really bad moment, because as you can see, when we have right here we have a cube, yeah, this is our a cube right here. So according to a fundamental theorem of algebra, we have three roots in total. So this is the first sign when you have a cubic equation. So in the beginning we have a cube equal to 3a. When we have a cubic equation right here, it means that we will have at least three roots. We don't know how many real numbers, how many complex number. It happens right here that we find three real number roots. First right here, second, and the third. So maybe a long explanation, but I think a lot of students watch my videos, and this is explanation for them. When you have the third power, when you have the fourth power, according to a fundamental theorem of algebra, we will have three roots in total. Okay, and basically when we have a square, we have two roots in total. We don't know how many real number, how many complex. This is like the maximum number of solutions, the maximum number of roots. So it's not like 100% two roots. It can be like one root, it can be like no roots, it can be two complex roots, but the maximum number of roots is 3. Right here the maximum number of roots is 2. So this is extremely important part. So I hope you understand this step. When we have a cubic equation, it means that you will have 3 roots in total. We don't know how many real numbers, how many complex numbers. We have 3 roots in total, and the same way is a quadratic equation. So I hope you understand my explanation. Let's write our final answer to this question, because a lot of students think that the answer is a first equal to 0, but as you can see we find our a second equal to square root of 3, and a third is equal to minus square root of 3. This is my graph. You also saw a graph from math library, so you can easily see that absolutely great solution. So this is my explanation to this question, a little bit long, but I think a lot of students watch my video, so I try to give them some hints, some information to this tricky question from math interview. As you can see, this question is created in a very tricky way. We can easily write it as a cube and 3a, but a lot of questions made like that. Okay, so doesn't matter. A cube, 3a, cubic function, linear function, factoring, and we find our solutions. Okay, so this is my explanation to this question. I hope you understand it. I hope you learned something new, but definitely don't feel bad if you got this wrong. If you need help with any of these classes, you can also write a question down into the comment section, write your notes about this question, and thank you everyone for your time. Thank you everyone for your support. Have a great day. Wish you all the best in your life, and see you in the next videos.